Good morning, fourth graders. Welcome back to math class. We have been talking recently about perimeter, and perimeter is measuring the distance around an object like a square or a rectangle or a triangle. I'm going to remind you of a picture that I showed you several days ago, kind of illustrating, I guess you could say, the difference of perimeter and what we're going to be talking about today. Today, we're not going to be talking about measuring the distance going around, called the perimeter. Today, we're focusing on the inside. Look on the inside of that fence. Do you see how that's all the grassy area? Hey, did you hear the word that I just used? Area. Area is exactly what we're going to be finding today. We're going to be finding how to measure the distance inside a specific area, not just around the edges, the whole surface. And I thought, well, how could I illustrate this? And then I thought, hey, let's use something that you might already have in your room to help teach and introduce this concept of area to use. So I got Mr. Evans and I, we've been watching a little TV, and we watched this show called Lego Master, which I learned that there is no plural of Lego. It's not Legos, it's just Lego. So something I learned from that show. So I went out and got me some little Lego here. It's the singular and the plural form. And don't look at the grass or the green part here, but look at this blue part. Look at my favorite color. Now, let's count how many pieces we have of this blue. Okay, let's count. 1, 2, 3, 4 going across. Let's count up. You ready? 1, 2, 3, 4 going up. If we have 4 going over and 4 going up, how many pieces do you think we have in all? Well, we could do a couple of things. We could count every single one of these little spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 little spots here. We could do like what I just did and count them all up, but there's actually a faster way to do that. We could multiply one length by the other, okay? One side by the other. What's 4 times 4? 16. So the area of this blue would be 16 square units. And I want you to notice how I said the word square units, because if I were to separate all of those little bitty Lego, they would be in little bitty squares, just like this one. So when you're talking about area, area is always in square units. Now, I have a different one I want to show you. This time, we're going to go from this one to that one. Can you figure out what the area of this is? 1, 2, 3, 4, 5, 6, 7. The area of this is 7 square units. I just counted them all up. Okay, which one is larger? This one, of course, the 16, right? Because 16 is greater than 7. All we had to do was count them up, or we could count the value of this, 3 going across, 2 going down. What's 3 times 2? 6. Plus 1, 7. So there's a couple of different ways that you can do that. How about this one? Ooh, might have to turn it this way. Can you figure out the area of this one? 12. Let's see how we got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units of measure. All we're doing is counting all the little dots up, and that's it. Now, for Lego, they're using little bitty dots. You're used to seeing all those little dots, right? In area, though, they're going to be using square units. Let's take a look at your book. Let's open up to page 259. And I want you to look at that first object. The first object there is in, not blue, my favorite color, but in yellow, sunshine yellow. I love that. I'd like for you to do just like what we did together and count up all the little squares that are located inside of that yellow square. Count them up. You can either count them up diagonally or vertically or horizontally, but however many you get at the end should be the area. Now, I know some of you are thinking, what's a shortcut? Maybe I could count going over and count going down, multiply them together? Sure. Okay, I want you to tell me the area on 3. 1, 2, 3. Hopefully, we got 36 square units, 36. How about for the next one? The red one. Now, the red one is a little different. Just like this guy was a little different. Remember, count up all the individual ones. It might be easier for you for this one to count however many you have going across and however many are going down. And then what? Maybe subtract 1 because 1 is left out. What was the area for the red? 21 square units. There was 21 little squares in there. How about for the last one, the green one? Now, before you jump ahead of me and start counting, I'd like for you to look at 2 of those squares. What has happened to 2 of those squares? It's like they've taken a knife and went, hi-ya, and they cut them diagonally in half. Well, let's think about that. If we have a half and a half, and we put them together, what does that equal? 1 whole. So when you're counting those squares, take the half and the half, put it together, and that'll equal 1 whole square. How many square units are represented in the green section? 16, great. Okay, so that's what it should look like right there. I'm trying to get as close as I can. 36, 21, 16. Okay, very good. So for area, I know it was just such a short, quick, brief introduction, but for area, we're counting, not measuring going around, but we're measuring and counting the inside of the surface. Just like we would never think about a soccer field. Would we ever just put grass around the edges of the soccer field? No. We put it along the whole area, the whole surface, because you want a large playing area, right? The bigger the playing area, the bigger the field, the more soccer you get to play, right? Area is kind of cool like that. Go down to section 2. Section 2, we're actually going to be reviewing our perimeter. We don't want to forget about what we've worked so hard on for the past few days. Let's look at section 2. I have section 2, letter C up on the board. This is a reminder to us that before you begin and jump into your perimeter formula, your measurements must match. We have 4 feet 8 inches. Oh, I already don't have a match there. And 16 inches. What actually here is the same unit of measure? Well, I've got an inch here. So why don't we just convert everything over to inches? This one's already done for us. Let's focus on the 4 feet. Remember, we're going from a foot to an inch. What is our rule? Larger to smaller, multiply. By what? What's our special number? By 12. 4 times 12 is 48 inches. Now, we can't forget about the 8 inches that we already have. So let's incorporate that with our answer. Let's add them together. 48 inches plus 8 inches is a total of how many inches? 56. We must have 56 inches first before we can begin with our perimeter formula. Okay, let's start. P equals 2 times L plus 2 times W. Don't forget about those parentheses. My L is now 56. My width is still 16. Parentheses mean, do me first, do me first. 2 times 6 is 12, carry the 1. 2 times 5 is 10, plus 1 is 11. 2 times 6 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 plus 2 is 4. 1 plus 3 is 4. 1 plus nothing is 1. Our label or our measurement is inches. The perimeter, or the distance around, is equal to 144 inches for section 2, letter C. Let's try a metric unit, shall we? Let's do letter F together. Okay, letter F, we're still dealing with a rectangle. 6 kilometers is our length. Our width is equal to 25 meters. Well, according to the instructions, they're wanting us to convert to the smaller unit of measure. What is smaller, a kilometer or a meter? A meter. Remember, the kilometer is the king of the measurements for the metric system. So let's go ahead and change kilometers to meters. Kilometer, big, meter, small, larger to smaller, multiply. What is our special number? How many meters does it take to equal 1 kilometer? 1,000. We could easily multiply this. 6 times 1,000 equals 6,000 meters is what we're going to be using. Let's start with our formula. P equals 2 times L plus 2 times W. Please make sure that you're working this in your book as we're working together. My width is 25. My length is 6,000. Why don't we go ahead and bring down those 3 zeros? 1, 2, 3. 2 times 6 is 12. If you have 2 groups of 25, that gives us 50. Add together, 0 plus 0, 0. 0 plus 5, 5. 0 plus 0, 0. 2 plus 0, 2. 1 plus 0, 1. And meter is our scale, or our measure, our unit of measure, I should say. Okay, if you would go ahead and turn the page, and we're going to do a few of those story problems together on the back. We're going to tackle the right-hand side together, and I'd like for you to try the left-hand side on your own. Let's look at letter D. Yesterday, Sydney finished her arithmetic worksheet in 30 minutes. Woohoo, good job for her. What part of an hour is 30 minutes? Remember, when we see this word, or these words, what part? That always means that our answer is going to be a fraction. Our answer will always be a fraction if we see what part in the question. So let's take a look. What part of an hour is 30 minutes? Well, let's put 30 on top because that's the part that we have. Excuse me. The part that we don't have is the total. Well, how many minutes are in one whole hour? 60 minutes. Remember, when we're talking about a fraction, the whole piece goes at the bottom. The part goes at the top as our numerator. Let's ask ourselves our 2 questions. Is this a proper fraction? Yes, it is. We know it's proper because the numerator is smaller than the denominator. Is this reduced? No, it's not reduced. So there are many different things that we can reduce by, but let's go back to our number one rule of reducing. Our number one rule of reducing is always trying to divide by the numerator first. $30 divided by 30 is 1. 60 divided by 30 is 2. What part of an hour did she finish her arithmetic worksheet in? 1/2 of an hour. 1/2 of an hour is our answer for section 3, letter D. Let's move down that right-hand side to 3E. Caden bought 4 pink roses to his teacher. He brought them to his teacher. How sweet. 4 roses is what part? Did you hear that? What part means our answer will be a fraction. 4 roses is what part of a dozen roses? Let's start with what we have for 3E, and that is 4. How many items does it take to equal 1 whole dozen? 12. That will be our denominator. Let's end by asking our 2 questions. Question number 1, is this a proper fraction? Yes. Question number 2, is it reduced? No. Let's reduce it. What will we reduce by? 4. Remember, our number 1 rule of reducing is try the numerator first. 4 divided by 4 is 1. 12 divided by 4 is 3. Our answer is what part of a dozen? 1/3 of a dozen. 1/3 of a dozen. You're doing great. Thanks for hanging in there with me. Section 3, letter F says, Miss Rodriguez, bought 9 mints for 72 cents. How much would a dozen mints cost at this rate? Well, we know how much it costs to buy 9, 72 cents. But we're not wanting to buy 9. We're wanting to buy 12. We're wanting to buy more than that. Well, why don't we figure out how much 1 costs? So let's take the amount that it took to buy the whole 9 and put that into equal groups of 9. If we take 72 cents, divide it into equal groups of 9, we will know how much 1 of those mints costs. Let's set it up like this for section 3, letter F. 72 cents, and we're putting that into equal groups, so that means that we're dividing by 9. Bring your dollar sign and your decimal point straight up. Can 9 fit into 7? No, ma'am. Can 9 fit into 72? Sure. How many times? 8. 8 times 9, 72. If the numbers are the same, 0 is the game. So it costs 8 cents for 1 mint. Well, if we're wanting to buy 12, we know the cost of 1. All we would have to do is take the 8 cents and add that to itself 12 times. 8 plus 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 8, and we would have it, right? Yes, we would, but there's such a faster way to go about that. Do you know? Multiplication. Let's take the 12 mints that we're wanting to purchase and multiply that by 8 cents. Oh my goodness, we totally know this. What is 12 times 8? Yeah, 96. 96. So it would cost 96 cents for 1 dozen, or for 12 mints. Isn't it so nice when we know our multiplication tables? It just makes it so much faster, so much easier. Let's do this last one, letter G. Ooh, a skateboard. Ryan bought a skateboard for $50. The skateboard was reduced $12. Reduced. That means the price was lowered $12. What was the original price? So it sounds like he got a good deal on it. I don't know if $50 is a good deal or not for a skateboard because I've never purchased one, but oh well, that's another story. So we know that he paid $50, but it was reduced $12. That means they took $12 off. And when the register, the cashier person at the register mentioned to him, he said, okay, everything's tallied up. You owe us $50, sir. Well, we're trying to figure out what is the original cost right here. How can we solve that? Well, what is the opposite of subtraction? Addition. So why don't we add the two numbers together? Let's do that. Here we go. $50 plus $12 equals how many dollars? 2, 6, $62. Well, let's plug that in and see if it works. 2 minus 2 is 0. 6 minus 1 is 5. Hey, that works. So sometimes doing the opposite is actually a way to find out the correct answer. So the original cost was $62. We found that out by taking how much he paid and adding back the $12 that the store saved him by the sale that was going on. All right, so let's just do a little bit of a recap. Today's main number one thing was to talk about area. Area is how much space is covered by something, whether it be Lego or whether it be a carpet or grass for a soccer field. When you're talking about one solid piece of surface, that's referring to area. And area is always measured in square units. Now, different from that would be perimeter. Perimeter is the distance around. Now, if I had some more border, which I do, but I could have taken that border and went not just along the top, but down and across all the way around. That border is my perimeter. The whiteboard is the area. So area is always in square units. Stay tuned. We're going to talk about more area in future lessons. I hope you have a terrific Tuesday, and I can't wait to see you soon. Bye-bye.